So here we go. We're graphing. We're going to talk about properties of rational functions. I think the most important part to write down is just what is a rational function. So a rational function is when you're dividing two terms that both have an x. And the main thing to keep in mind is that the denominator cannot equal 0. So when we're graphing a rational, there are 4 pieces and that's where the darker pink sheet comes into play. The 4 components of a rational function. So we're going to graph today, Monday and Tuesday. You already have the study guide, and I actually already posted the answer key to the study guide, and just like the quiz, I posted the videos to go along with that. So you have it to study, to start studying. So everything that was on the quiz is going to be on the test, except you will have a few graphs added in addition to that. I did grade the quizzes, and those are also in Skyward. If I have a chance, I'll show you. Well, I will show you at the end of class so you can see. Retakes can be done. I stay after on Tuesdays. If you have a study hall, we can make an arrangement for you to come during that study hall also. Okay, so let's talk about the first piece, which is the roots. So the roots of a rational, because you have to remember, a rational is 2 functions. It's a fraction. You have a numerator and a denominator. So roots, another word for root is your x-intercepts. This is on your pink paper, so you don't need to, the dark pink paper, sorry. So everybody look at your dark pink paper. Every time you see this little cartoon letter, that means it's on your dark pink paper, so you don't need to write this down. So just know or underline that the roots are going to come from the top. That's always going to be from the numerator. So your x-intercepts, which are your roots, that comes from setting the numerator equal to 0 and solving it. And you're going to write that as a point. So remember, for an x-intercept, y is 0, so it's a number in 0. Now this is really, really important here. It says the graph must pass through any roots, and it cannot cross in any other place. So this is telling you where the graph crosses the x-axis, okay? And depending on if it's a quadratic, it could be 2 different places. If it's a linear, it could only be 1. Now, there is a special case that we'll talk about, and that's when it's not just a single fraction. If it's not just a single fraction, then we have to set it equal to 0. So I'm going to give you an example of what I mean by. So if you see something where, for example, if you see 2x plus 1 over x minus 3, okay? That is just look at your numerator, okay? Look at your numerator, set that equal to 0, and solve it. But a special case would be if you see a 2x plus 1 over x minus 3, and I add a plus 4, okay? That's what I mean by a special case. If I'm adding something off to the side or subtracting something off to the side, then we can't just look at the numerator. We have to treat these two differently. Okay. So the other, and at the very bottom of that paper, we're going to talk about the y-intercept. So to find the y-intercept, we're going to plug the 0 in for x and solve it for y and simplify it. So this is at the bottom. So we're going to talk about the r and the y. Okay. So now let's go ahead and do a couple of examples. So copy down, we'll just write down one at a time. Copy down this first example, and we're going to find the x-intercepts and the y-intercepts of this function. So this is not a special case. Sorry, one second. I'm good. Yes, you did. Yes, you did. I'm gonna sit down and read through the email. I didn't just to look through the documents or anything, but yeah, I probably do, because I'm not sure how to. Okay. Okay, thank you so much, I appreciate it. All right. Okay, so this one is not a special case. So we can just focus on the numerator. So to find your x-intercepts, the x-intercepts, and the reason why this is not a special case is because we don't have a constant being added. That's what I mean by a special case, okay? So we don't have that. We don't have a number being added or subtracted, so we can just focus on the top. So your x-intercepts are going to come from factoring the numerator. Go ahead and factor that down and find your two x-intercepts. So you need two numbers that multiply to be -8 and add to -2. So that's going to factor down to x minus 4 and x plus 2. So that means you have an x-intercept at +4. And you also have one at -2. And those are the only two places where the graph can cross the x-axis. So now let's find the y-intercept. And if you look at the bottom of your dark pink sheet, it says to find the y-intercept, you substitute a 0 in for x. So you'll have y equals 0 squared minus 2 times 0 minus 8. 0 squared plus 2 times 0 minus 15. Go ahead and write that as an ordered pair. Simplify that. So we're substituting in a 0 for x. That's how you find your y-intercept. Now, of course, anytime you multiply something by 0, it cancels out. So these are going to cancel. And you'll be left with the -8 over a -15. Two negatives become positive. And we'll just leave that as a fraction. Don't write it as a decimal. Your y-intercept is at 0 and at +8 over 15. And that would be your x and y intercepts. No, so it's just whenever you have two negative numbers, it changes to a positive. So a negative divided by a negative becomes positive. But if only one of them was negative, so let's say this was a +8 and a -15, then the fraction would stay negative. So two negatives become positive. Okay, any questions about that first example? Okay, let's look at our second example. Go ahead and copy that one down. And we'll do the same thing. We'll find our x and y intercepts. So this is a special case. Does everyone see why this is different? Okay, so this is a special case, isn't it? It's because we have a constant that's also being added. So because of that, or being subtracted, I should say, we're going to treat it differently. So let's find our x-intercepts. If you look back at your dark pink paper, it tells you that for a special case, if the function is not written as a, and maybe you should write on that pink paper that this means that it is not written as a single fraction. That's what that means. It's not a single fraction. It's a fraction and then plus or minus something. That's a special case. When that happens, we're going to set the entire function equal to 0 and solve it for x. That's what we're going to do when it's a special function. Okay, so what we're going to do is replace this f of x with a 0. So we have 0 equals 4 over x plus 3 minus 2. And we have to solve that equation for x. First thing we would do is add the 2. So we have 2 equals 4 over x plus 3. So we brought that 2 over because it was negative, we had to add it. And then I always think it's easier to think of it as a proportion. So I'm going to write this as a fraction. Go ahead and cross multiply it. So you're going to take 2 times x plus 3. So you're going to have 2 times x plus 3 and set that equal to 4 times 1. Or 4. So go ahead and solve that for x. Distribute the 2, or you could divide the 2, whichever way. Go ahead and solve that for x. So I'm gonna distribute because I think that's what most of you all would do, is distribute. So that gives you 2x plus 6 equals 4. Subtract the 6. 2x equals negative 2. Divide by 2, you get x equals negative 1. So your x-intercept would be at negative 1, 0. So that is my x-intercept. Who had that for their x-intercept? Good. Now go ahead and find your y-intercept. For your y-intercept, you have y equals 4 divided by, and then it would be a 0, plus 3 minus 2. So that one is going to be a fraction or a decimal. So go ahead and see what you get for that. So I'm just going to type this one in my calculator. So you have 4/3 minus 2. Which is negative 2/3. So your y-intercept, and I'll write it at the top, would be at 0, negative 2/3. That's your y-intercept. Okay, let's go ahead and talk about the domain. Remember, your domain is everything except where q of x equals 0. And remember, your domain, because you cannot divide by 0, maybe instead of saying everything except where q of x equals 0, it's everything except where the denominator is equal to 0. So to find your domain, we're going to solve your denominator. Go ahead and factor and solve your denominator. So removable discontinuity is the place where we have where something is going to cancel out. All right, so factor top and bottom. I'm going to pass out your grade sheets. If I didn't see your parent yesterday, I still have your grade sheet. Although your grades have changed because I entered a quiz. So maybe I shouldn't pass it out. But I want you to focus on the homework component, because if your homework scores are really low, that could be a factor as to why your grade is what it is. So I already have them printed, so I'll go ahead and pass those out now. It has a signature at the bottom, but I don't need those back. I don't know how to get that not to print on there. So this was your grade before I put in the quiz. So truthfully, some of your grades went up, some of the grades went down. So let me finish this out real quick. So what does the numerator factor down to? What two numbers multiply to be 8 but add to -6? -2 and -4. On your denominator, what multiplies to be -12 but adds to a +4? What'd you say, Shyla? +6 and -2. Okay, who factored it down that way? So what do you notice is going to be, what can I remove? Right, this cancels. Okay. So that means that I have a hole where x minus 2 equals 0. So there's going to be a hole at x equals 2. Now to find the y value, because after you cancel that out, you're left with x minus 4 over x plus 6. So what you need to do is take that 2 that you have right here, take the 2 to figure out, well, we know that the hole is going to be at x equals 2, but what does y equal at that place? So that will be 2 minus 4 over 2 plus 6. So what I'm doing is I took that 2 and I put it in the function that I have left, because this is the function I'm going to use now to graph. After you remove the x minus 2, we have x minus 4 over x plus 6. So that gives you -2 over 8, or -1/4. So there is a hole at 2, -1/4. That's where the hole is going to occur. Okay, so I'm going to show you your quizzes. We'll stop there.